Thank you, Woody. It's a pleasure to be here today, and I'm normally a bit of a wanderer, but we're recording, so I'm going to try and stay put. If I wander, somebody just direct me back to this direction here. So I put together a presentation called Agave's 101, a basic primer. So often we'll go to presentations and we'll see a lot of pretty pictures of plants, but there's really sometimes no rhyme or reason as to how those plants are grouped together or organized. And I thought, well, I want to try and get that across to you today. So that's the focal point of this talk, is how are agaves grouped together? What are the main subdivisions? So it's a little bit of nomenclature and taxonomy, more so than just pictures. So hopefully everybody will stay awake. Hopefully I'll stay awake through the program. I know we've had a belly full of lunch here, so we'll get going on this. So plant nomenclature prior to Carl Linnaeus, we used to have to describe the plant in all these long flowing terms here, or glowing terms. So Solanum, Colli, Inermi, Herbaceae, Folius, Pinnatus, Incisus. A loose translation is that Solanum with a smooth stem, which is herbaceous and has incised pinnate leaves. So can you imagine holding a conversation with somebody, and every time you wanted to refer to this plant, you had to go through all of these gyrations. So Linnaeus devised the binomial systems, which we all know today. So instead of trying to describe, say, Astrophytum myriostigma as that 5-ribbed cactus with the white flecks all over it that grows kind of tall. Sometimes it doesn't have 5 ribs, it'll have 4 ribs. And it looks kind of like a bishop's cap, or a cap that a bishop might wear. So you have to introduce that every time you're talking about that plant. So instead you have Astrophytum myriostigma as one of your talking points. So Linnaeus formalized modern classification and provided the binomial system that we use today. So some important agave taxonomists. Here we have Joseph Salmdick. I'll forget the other, or skip the other part. He's known by the Salmdick. In 1834, he arranged the 36 species into 3 unranked groups. He called them the Caulescens, Acolles, and Herbaceae. And then in 1859, he took 45 species and arranged them into 5 groups, ignoring his previous grouping. Then George von Jacobi, he came along in 1864, and he produced his monograph in which he created 4 groups, and he called them the Keratocanthi, Chondrocanthae, Inermes, and Herbaceae. The next guy along was Alvin Berger, and he did a monograph in 1915 called Die Agaven. I don't read German, but with the help of Google Translate, you can pretty much get through most of what he talks about. But he divided the genus into 3 subgenera. So this is the first instance of dividing a genus into subgenera. So I don't know how familiar you are with the organization of the ranks between genus and species, but that's what we're going to focus on a little bit right now. So he divided them into the 3 subgenera, Lidii, U. agave, and Manfreda. And then all in all, he treated 274 species. Then William Trelease was pretty much a contemporary of Berger's, but because of World War I, those two really couldn't communicate, so they didn't know what each one was doing. But Trelease provided the treatment on agaves for Stanley's Trees and Shrubs of Mexico. And that's kind of the basis for North American taxonomists to work off of and study the agaves from there. So in that, he covered 170 species, 76 of which he described as new. So he was very prolific. He was also working on the pipers, Piperaceae, not the panpipes or anything like that, but Piperaceae, and he was very well versed in those as well. So many of his species were later reduced to synonymy. Some of those are being reevaluated and re-elevated to species level. What is synonymy? Synonymy is taking a name and subsuming it into another species because you believe it's the same thing. So you'll see in some books or papers, you'll see the accepted name and then lists of synonyms under that as well. Then we have Howard Scott Gentry. He came along in 1982 and published his monograph, Agaves of Continental North America. He spent about 50 years in the field, primarily looking at beans, phaseolus. He was employed by the USDA to look at phaseolus and try and bring crops in for production in the U.S. And while he was doing that, he studied the agaves and he taught himself how best to treat agaves in terms of skinning the leaves so you can make herbarium specimens. Now, I know sometimes earlier yesterday, taxonomists seem to be getting a bad reputation, and it was referred to as dusty specimens in a herbarium. I think that's very important that we have these dusty specimens in herbaria, because those dusty specimens were the basis for that description of a particular species. So they're very important for taxonomists to refer back to. And if you don't know where the type locality is, you need to look at those specimens and work from there. But Gentry did a lot of that, and he was the first one to actually use floral morphology. He looked at the flowers, and he used those to group plants together. Now, Gentry did some informal taxonomy. So in the agave in the strict sense, as Gentry defined it, is currently divided into two subgenera. So that's the rank directly below genus. And he based those on the inflorescence structure. So what we have here is the agave subgenus has the branched flowered stalk, and Lidii has the unbranched flower stalk. So agave branched and Lidii unbranched. So we'll look at those as we go along here. So here's the nomenclatural hierarchy. So we have the family. I still use Agavaceae. It's been put into Asparagaceae now. I'm not into family squabbles, so we're just going to stick with Agavaceae. Our next big division is the genus Agave. And then under that, we have the subgenera, Lidii and subgenus Agave. And then under that, Gentry used the term groups, which is an informal taxonomic rank, but the formal taxonomic rank are sections. And so we have sections under those. So I just picked one example. There's more than one section under each subgenus. So here we see the Striati plus 6 other sections under the subgenus Lidii. Under subgenus Agave, we have, for example, the Crenati plus 11 other sections. And then under those, we have species. So the binomial system, we use genus and species, but grouping them together, we have sections and subgenus above those, or in between those two. Okay, nature rarely works that way, and there are always exceptions to the rule. A couple of examples, first of all, they can be subject to various types of evolution, and that selection that gives cladisticians fits. So a couple of examples here. Reticulate evolution is characterized by the occasional hybridization between two species, and then you end up with different things happening. And this gives geneticists and cladisticians fits, because they don't know quite what to do with these things, because it's not a direct descending evolutionary line. And then disruptive selection, more than one trait is selected in evolution and possibly leading to two different species. Okay, so what I'd like to do is go through some of the characteristics of each subgenus and show that those characteristics are not exclusive to that subgenus. Okay, so under subgenus Agave, we have the branched inflorescence. So here's Agave shawii, which you'll see in Southern California and Baja California. But we've got that nice branched inflorescence. And here you can see the longer branches on that one with all the flowers clustered at the ends of those branches. Another example for the subgenus Agave is Agave Pari. This is up on Mount Lemmon outside of my hometown, and you can see the side branches here with all the flowers clustered at the ends of the side branches. Agave deserti. It doesn't look like it's got side branches, but if you look, if you look closely, you'll see that there are clusters or umbels of flowers clustered at the ends of these very short side branches. Agave Montana is another good example of the subgenus Agave. We've got the flowers, again, clustered at the ends of the side branches. Okay, subgenus Lidii, they don't have those very long or sometimes short side branches, and all the flowers are on very short pedicels, pretty much attached directly to the main stalk. So you'll see the flowers are packed together all along that main stalk, and that's the key characteristic for this subgenus. Agave striata has the same type of arrangement, as does Agave pelona and Agave potrerana. So these are all types of Lidii with the flowers more or less on short pedicels directly on the main stalk. So those are the two main subgenera. And sometimes you look at these things, and some of those plants we saw, most of the subgenus Agave had really broad leaves. A lot of the subgenus Lidii have narrow leaves. Is that always the case? No, it's not. We'll look at some of the leaves as well. But first, we've got some of the renegades, some hybrids. So this is a hybrid between the two different subgenera. You can see the short side branches here with flowers clustered at the end. So that's characteristic of the subgenus Agave. But it's got a much longer inflorescence, more characteristic of the Lidii. So we've got hybrids between those two. So that's one. And here's another one that's a good example. We have Agave chrysantha, a branched one. It's not quite flowering yet, but it's on its way. We have Agave tumiana, is a spicate type, unbranched. And in between those, or hybrid between those two, we have Agave arizonica, or X arizonica. And you can see the development of the side branches that are going to be very short with flowers at the end, but a long inflorescence there. So that's a hybrid between Agave chrysantha and tumiana. Here's tumiana down here. So we've got both parents and the hybrid together, growing side by side. Okay, agaves can either be solitary or produce offsets regardless of which type of inflorescence. So both subgenera will produce, some plants will produce offsets, some will be solitary. So let's look at some of those examples as well. In the subgenus Agave, we'll look at some of the solitary types. Agave guadalajarana, typically solitary in habitat. Agave avellanidens, again, typically solitary in habitat. And Agave Montana, solitary in habitat. And then in subgenus Lidii, we have some solitary types as well. Agave shedigra is solitary in habitat. Agave vilmariniana, now it was referred to as a sad-looking specimen. I love this look on there. I'd love to be able to grow one that looks like this. We bring it into cultivation, all the leaves grow upright, and they look completely different and not as attractive as this does. Then Agave impressa is typically solitary in habitat as well. So offsetting types, and we'll look at some in the subgenus Agave. Agave deserti, you can see it produces a lot of offsets, and this one's died off, and there are offsets going, and they make great big clusters of plants for this species. Agave pringlei, same type of thing. You can see this plant's flowered and died, There's the next one. One of these two will go next, but there are plenty of offsets here, and there are offsets going off of it, making a big cluster over here, more clusters over there. So we have the unbranched type producing offsets as well. Or the branch types, I'm sorry. And subgenus Agave, Agave Pari, you can see the mother rosette here with offsets coming out there. Agave asperima, again, you can see the mother plants are flowering. There's lots of offsets, so they make great big clusters of plants. Okay, subgenus Liddy with the offsetting types. Agave striata, you can see this one's flowered, these are flowering, and they will produce offsets as well to make great big clusters. Agave tumiana, it'll produce a lot of offsets. Again, we see the lack of plants in the middle. They flowered out and have died off and decomposed some, and you've got more offsets to carry that genetic line through. Agave triangularis, same type of thing. The mother plant was in here, it's flowered and died off, and there are lots of offsets to carry that genetic line. So Garcia Mendoza, it will offset even on these types of limestone slabs here. You can see wherever there's a little crack, an offset will come out. We'll see some seedlings as well, but if there's a crack big enough, you've got the main plant and then offsets coming off of those. Okay, so then there are those types that are simply confused about whether they want to offset or remain solitary. Agave Victoria Reginae. Growing them in pots, there are some forms that will be solitary, and there are some forms that will produce a lot of offsets when they're little plants. And then as they reach their teenage years, they'll say, you know, I'm not going to produce offsets. But then just before they flower, they'll start to produce a ton of offsets again. So she's not quite sure what she wants to do. Typically in habitat, you don't see so many offsets, but in cultivation, they can produce tons of them. Agave ovatifolia. For the most part in habitat, they're solitary. You'll see the occasional offset once in a while, but not too frequently. In cultivation though, in pots, in cultivation I should say, they'll produce a lot of offsets. Some forms will at least. Put those in the ground, they tend not to offset. So it hasn't quite made up its mind as to what it wants to do. Agave parasana, similar type of thing. In habitat, no offsets. In cultivation, there are forms that will produce dozens of offsets. So leaf size, we talked about that a little bit earlier. Frequently, but not always, the paniculate plants or paniculate inflorescence types tend to have broader leaves, but that's not always the case. And consequently, plants with the spicate inflorescences tend to have narrower leaves, but that's not always the case as well. So here we have Agave Montana. It's got the big broad leaves on it, and you see that plant without the flowers. You see the big broad leaves. You say, oh, I bet that's a paniculate type. Well, you'd be right. Same with ovatifolia. It's got big broad leaves, and yes, it does have a paniculate inflorescence. Agave datilio, on the other hand, has a paniculate inflorescence, but it's got very narrow leaves, which you'd more commonly associate with the spicate type of inflorescence. Agave teckelana tends to have narrow leaves as well, but it's a paniculate type when it does get to flower. Most of these are cultivated plants. They'll let some go to flowering so they can pull bulbils off of the inflorescence, but for the most part, these things are harvested before they get to flower. Then we have a spicate type, Agave Vasquez Garcia, and it has broader leaves than something like Agave striata. So we can see the broad leaves here, but it's a spicate type. You can see the spicate inflorescences back there. So it's not always the case that broad leaves and paniculate inflorescences go together. Agave pedunculifera, this also has a spicate inflorescence and very broad leaves. I mean, we can see those nice big broad leaves on this plant here. Agave striata, on the other hand, has very narrow leaves, and it's a spicate type. So you can see the leaves here, they're very, very narrow. Agave Victoria reginae, somewhat in between. They're narrower than something like Vasquez Garcia, but not as narrow as striata. But you can see the spicate type with the mostly narrow leaves. Now, do they all die after flowering? Well, no, they don't. And we'll look at some of those. So, plants, Gentry coined the term, well, I don't know if he coined it, but he used the term monocarpic for agaves. Now, they're not all monocarpic, but monocarpic means that it flowers once and then dies. He pretty much used the term multi-annual as well for plants that will grow for many, 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 many years, flower and then die. So they grew many years and died, flowered once and then died. So they were, in essence, a long-lived annual. They grew more than 1 year, but so he used the term multi-annual. So here we can see Agave Pari is dying after it flowers. Now, Pari, we saw earlier on, does produce offsets, so it has those offsets to continue that particular genetic line, but it will flower and produce seed as well. So it has outcrossing and it has a good genetic base to continue the population. Agave palmeri, it does not offset, so once that particular plant flowers, it dies. That genetic line, that one genetic line is gone, and it has to rely on flowering to continue the genetics there. Polycarpic means that a plant can flower repeatedly, forming new rosettes in the upper leaf axils. Now that's not unusual. You say, oh boy, I thought all agaves died, and that seems so unusual for that to happen. But if you look at a tree or a shrub, this is basically what these plants do. They flower at the apex of the rosette, but they have the capability of producing offsets from the leaf axils, just like any other leafy plant, like a tree or shrub. So it's not that unusual. Just in agave terminology or agave life, it is a little bit unusual. So there are two main groups or sections that do that. So the striati does that. Plants in the striati, all except Agave dazzlerioides, and then plants in the polycephaly will do that as well. And polycephaly is aptly named because poly is many and cephaly is head, so it produces many heads. So it can do that. It flowers and then produces many rosettes from that one rosette. And here's an example of that. We can see, I'm blinded by the light. So we're seeing the flower come out of this rosette, but we see a new rosette growing from the leaf axil of this leaf here. So it's going to produce many heads eventually. Brian Kimball has at Ruth Bancroft Garden. Brian, how many inflorescences have you had produced on a clump of Agave Celsi? Are you here? 18 inflorescences. That's must make quite a display. Okay, so where do agaves grow? Agaves, they're all New World, and they can be found in the southwestern U.S. as far north as southern Utah and adjacent Nevada. The furthest north that I've seen it is up around Rachel, Nevada, which is not quite central Nevada, but up there along the extraterrestrial highway. I did not get abducted while we were going to see those. They grow south throughout Mexico, into Central America, and also in the Caribbean and South America. Agave utahensis, this is one of the most northerly populations for agaves. And Agave cordillerensis, this is probably the southernmost population of agaves, or one of the southernmost. This was in Peru. down here. When I first saw this, I took it to be Agave Americana. Then my friend Tristan Davis, I sent him this picture. He says, oh, I bet that's that newly described one, Agave Cordillerensis. And I looked that up, and sure enough, it fit the bill. So it was kind of a new one for me on my bucket list. I got to scratch that one off. So where do they grow? Sometimes they're found at very low elevation. The sweet spot tends to be mid-elevation, and then some grow at very high elevation. So let's look at a couple of examples. Agave Sebastiana is one of those low elevation ones. You can see this is on Cedros Island, and you can see the Pacific right here within spitting distance of the plant. Agave Xiaoyai also right along near the coast there, within sight of the Pacific Ocean. Then we've got Agave Tumiana variety Bella. That's about 2,000 to 2,500 feet in central Arizona. So it's about the mid-elevation one. So it's in its sweet spot here. So most of them, I don't know, I'd say most of them grow definitely not at the very low elevation and not at the very high elevation, but there's that range in between where most of them do grow. Agave Montana is one of the high elevation ones. Typically it's found at 3,000 meters or 9,000 feet and above. And it's a very high elevation one. This is always one of my favorite ones to see in habitat. Okay, so where else do they grow? Some grow in hyper-arid regions, or very few of them do. Most of them grow in areas that receive moderate amounts of rainfall, and a few of them grow in areas that receive high amounts of rainfall. So let's look at a couple of examples. Agave Turneri is one of those from a hyper-arid region. This is in northeastern Baja California. Actually, it's only about 35 miles south of Mexicali along the Baja California coast. And it's in the range called the Sierra Cucapá, which probably receives less than 2 centimeters of rainfall annually. So it's one of those hyper-arid regions. And it grows on this cool rock they call Monza granite. So I think to grow this one, I don't know that we need to reproduce that type of rock, but it would be very interesting to grow this in that type of rock. It's this white rock out there, and you can drive out, when you drive past the Sierra Cucapá, you can look back in there and see the white rock, and you can guess that's where the Agave Turneris are growing. Agave Chrysantha is one of those at the mid-elevation, so it gets a little bit more rainfall, probably around 22 inches of rainfall a year for this one, as does the Agave Tumiana. And then Agave Midas grows at a little bit higher elevation or in more moist situations, and I would suspect that around 20 inches or more of rainfall fall where this one grows. Okay, what type of soil do they prefer? Some are indifferent to the type of soil. Some prefer a certain type of soil. Kelly talked about Agave gypsicola growing on gypsum. We've got some that like limestone, gypsum, and others go out of their way to avoid those and grow in anything but that. So Agave Pelona loves limestone. This is I'm going to bug Jeff with this one, a steep cliff. Not a shallowly sloping cliff. It's a very steep limestone outcrop here, and the Agave Pelonas are pretty much plastered on those limestone cliffs. The Pelonas, I've seen them about 2 feet in diameter, not much bigger than that. Tightnota likes limestone as well. You can see all the, go back, you can see all the limestone cliffs here and all the blue Agave Tightnotas out there. Agave gypsicola, so named because it grows on gypsum for the most part. Agave Turneri, it likes, like I said earlier, the Monza granite soil, and you can see all that white soil there. Very crumbly stuff, very attractive plant set up against that interesting backdrop there, and really cool looking rock. Then Agave palmari seems to have no preference, and it'll grow in the grasslands of southeastern Arizona. Okay, agaves sometimes will produce incredible colors. We've got the fall colors, I put fall in quotes, the fall colors of Agave Montana. Now when Agave Montana starts to bloom, it will produce some incredible colors. Some of the plants will. They'll do reds, purples, yellows, oranges as well. And I equate that to the fall colors of living back east. So anytime I want to see fall color, I go up to the high mountains of Tamaulipas to see these plants.
Do they make the same color in a lower elevation?
Well, that's only a high elevation one.
Okay.
So up in habitat, I've never had one go to flower. Now, Brian, you've had one flower out? Did it color up when it flowered? Yeah, you get the special one. So, yeah, I haven't had it flower, so I don't know about it coloring in cultivation or not. Brian's experience with his plant was no, it didn't. So here's Agave Kyotopecensis. It does not need to flower. It'll color up in the dry season. In the wet season, it'll go a little bit greener. Agave convalis. This is one of those that William Trelease described in 1920. It got subsumed into Agave Kirchovi. Abisai Garcia Mendoza elevated it back to or re-recognized it as a valid species. So Agave convalis, frequently you'll see these incredible colors of reds and purples, sometimes green with red on those, but not all plants will do that. Agave gentry, sometimes when it blooms, some plants will produce these great colors here. It's a little bit more orange. Sometimes we've seen yellow ones. Brian and I were down on Cerro Potosí in Nuevo León. We saw this one off in the distance and had to bushwhack our way through the chest-high spiny shrubs to get to that plant. And then Agave Montana, the special one, will produce incredible colors as well. We had the orangey reds, some yellows, more reds. And that's it for the program.